Let's talk about Rolle's theorem. First video, just the idea. It's really one of those theorems that's pretty intuitive in terms of the picture, and I'm going to let the book take care of the careful proof, which relates to some deep ideas, but that's not really what we're focusing on. The way I like to say the idea is we're talking about Scooter, our often irresponsible intern, and he's went from Albuquerque, went north on I-25. We noticed him leaving at noon, let's say that's t equals 0. And then we noticed, and we expected him to go to Santa Fe and stay there, and we hope he stays there forever. But we noticed that at t equals 4, say 4 hours, 4 o'clock p.m., he's back. And so he's back to where he started. And we're like, Scooter, why did you turn around? And he says, I never turned around. Like, you never turned around? You went north and then south? Did you get off I-25? No, I was on I-25 the whole time. Straight road, didn't take any turns, anything like that. But I never turned around. But how could you start here, go north, and then end up at the same place and not turn around? Did you ever get to northward velocity equals 0? Like, no, I didn't. Like, how can you do that, Scooter? You must be lying, because at some point, he must have achieved some maximum northwardness and come down. Maybe he had other things in between, stops and starts and up and down, but he must have turned around somewhere. If we graph his position as a function of time, let's say s. It's often what we use for position. Okay. He started out here. He ended here. Whatever the heck he's doing in here, there must be some turnaround. And the careful proof really focuses on the fact that there must be a maximum. And at that maximum, he must turn around. So it must look something like this. Maybe he had more than one, whatever. But there must be at least one place where the derivative is 0. And so we'd say there's some c where the derivative is 0. Now, let's think about this a little more carefully. We do want to see, even though we're not going to look at the proof super carefully, we want to look at the hypotheses. There are ways, theoretically, mathematically, that Scooter could violate this. Okay, there are pictures where you start from the same height as you end, and you don't actually have f prime equals 0. So first of all, you could have something that, we've seen this when we talk about IVT, the intermediate value theorem. He could have done an infinite teleport or something like that. Okay, or he could have done a finite teleport. Here, everywhere the derivative exists, he's going northward. And he actually snuck up on us from the southward because he could teleport. Okay, so these would make the conclusion that there's some stationary point, some place where f prime is c equals 0. That would make that false. But of course, we know from IVT that these are ways that we don't want to allow Scooter to cheat. And physically, a car can't actually do this. Well, it's more subtle here with Rolle's theorem because, very much like our subtleties about bad versus good critical points, he could start here, end up here, in terms of s versus t, and he could actually have a sharp corner. Okay. So here f prime of c does not exist, is not equal to 0. And there's no place in this interval where it's equal to 0. But those are the claim of Rolle's theorem is those are the only ways you could cheat, and it's usually pretty easy for us to determine either from physical principles or from the formula for a function that you can't, that you are going to be continuous. So these are off the table, and you're differentiable. Let me say why physically, even if we didn't know the formula for this function, why physically this would be ridiculous. He's going north, let's say, at 75 miles per hour. And then by this assumption, instantaneously, he's going south. So his slope is now minus 75 miles per hour. He changed velocity by 150 miles per hour in 0 time. That's an infinite acceleration, roughly speaking. We would really say, hey, it's not differentiable, to be careful mathematically, but if you had to put some sort of physics in it, it's an infinite downward acceleration. Basically, it's very close to, he actually got in the wrong side of I-25 and smashed into a very, very heavy truck that changed his velocity from northward to southward very, very, very quickly. He got smashed into jelly. That's not really good for Scooter. Even though we're kind of annoyed with Scooter a lot of the time. We don't want that to happen to them. Okay, so the way Rolle's theorem is stated, I'll end this one with the careful statement, and then give an example of using it in a very particular case, and kind of playing with the logic a little bit, because often you play with the logic a little bit on this one. So if f is continuous on a whole closed interval, and it has to be all the way to the endpoints, so you don't teleport at the last minute or the first second, okay? And we're gonna require that it's differentiable. It starts out just like the statement of IBT, and it's very similar in feel to IBT. And the mean value theorem, that's going to be a generalization of this, is going to be similar to that. And if f is differentiable, it turns out, even if he tries to cheat by not being differentiable right at the endpoints, it doesn't help him. And he comes back to the same position, or just the function has the same value at the two endpoints. Then there is, and this is similar to, it feels again similar to IBT. It's asserting abstractly the existence of some special point, but doesn't tell you where it is. But here it's not asserting the existence of a place where the function gives some special value. It's saying that there is a stationary point, a good critical point, a point where the derivative is equal to 0. And that's that turnaround. So again, if you stop at the same place you start, you come back to the same place you start, and you can only move along a line. We're not talking about moving in circles here. Then you've got to have turned around at some point. In the next one, we'll see how to use it.